This section deals with logarithmic functions. Remember, an exponential function will look more or less like this when we graph it. Now, is this function one-to-one? Remember, we would use the horizontal line test to see that. So every horizontal line here that it crosses it only crosses at most one spot. So because exponential functions are one-to-one, they have to have an inverse, right? According to our definition, if a function is one-to-one, it has an inverse. Well, the inverse of exponential functions are logarithmic functions. Let's look at the definitions of logs and how they correspond to exponentials. So the definition of logs is as follows. Y equals the log base a of x. So this was said y equals the log base a, so that a is called the base a of x, if and only if a raised to the y is equal to x. So definition of log says y equals log base a of x if and only if a to the y is equal to x. So if you look at here, the bases for these problems stay the same, right? Because this is considered a base and this is a base, but my x and y have been swapped. So here my x was with my a, now my y is with my a for exponentials. Here we were equal to y, here we're equal to x for exponentials. So bases are the same, you swap your x's and your y. Why do we do that? Well, remember, in order to find inverses, what did we have to do? We had to swap our x's and y's. So logarithmic functions are the inverses of exponentials. Let's look at a couple of notes here, and then we're going to practice kind of going between exponential and logarithmic form. So first, if you don't have a base, if you have a log that does not have a base, for example, this log of x, your base is automatically 10. So if no base, if there's no little base down here, if there's no a or 2 or 5 or 7 or what have you, it's an implied 10. Also, we don't write log base e. Remember, e is that natural exponent? We don't say log base e. Log base e is actually said natural log, or ln. Whenever you see ln, that implies log base e. Let's look at some properties of logs. The first one is log base a of a. A here, that I'm putting parentheses around, this is called your argument. That's what you're taking the log of. So if the base and the argument match, if the base, because this is log base a, if the base and the argument match, your answer is just 1. If you are trying to take the log of 1, if your argument is 1, your answer is always 0. Again, when the base and the argument match for this third one, they'll cancel, that'll equal 1, so you're just going to have r left for log base a of a to the r. Next one, if you have a raised to the log base a, so your base and base are the same, this is always just equal to r. Let's look at it in terms of the natural log side. Let's put all our arguments in parentheses. So here my argument is e. Well, what's the base? Remember, the natural log is log base e, so this is really log base e of e. Well, when your base and your argument match, your answer is always 1. Natural log of 1. When you're taking the natural log of 1, or when you're taking the log of 1, when your argument is 1, your answer is always 0. Natural log of e raised to the r, the natural log and the e will cancel out and you're just left with r. E to the natural log, well, e to the natural log, because your bases will be the same, will cancel, and you're just left with r. So these are just some properties. These come up a little more often than the bottom ones, but you should try to commit most of these to memory. Let's practice with our definition of logs here. So for the first 4 examples, it is asking us to rewrite the following in logarithmic form. Let me write the definition again because we've scrolled and we can't see it. What we said before was y is equal to log base a of x if and only if, this is if and only if and only if a, and then I swap my x and y. A to the y is equal to x. Well, this is in exponential form. I want to write it in logarithmic form. So what you want to do is first identify your base. Well, I have 4 to the third is equal to 64. So the base here is 4. So that means that this is going to be log base 4. Then I need to switch the numbers. If 3 was with my 4, now 64 comes with my 4, and 3 goes on the other side. So because 4 cubed is equal to 64, the log base 4 of 64 is equal to 3. Again, base stays the same, and you swap the x and y. Here it's the 3 and 64. Let's do number 2. Right, identify your base. Your base is 8, so the log base 8. Now 0 is here with your 8, so 1 now becomes your argument, and that's equal to 0. So this says that the log base 8 of 1 is equal to 0. Well, we know that to be true because we just said here log base a of 1 is always going to give us 0. So I don't care what the base is. If your argument is 1, it's going to be 0. And the reason for that is because a number raised to the 0 power is equal to 1. Well, let's look at this one. Well, this one looks a little strange because I don't have an exponent. Well, the cubed root of 8 is the same as saying 8 to the 1/3 power. So this is really 8 to the 1/3 power is equal to 2. So what is your base? Well, my base is 8, so we rewrite this as the log base 8, and then swap your numbers here. 2 now comes as your argument, and 1/3 goes on the other side. So the log base 8 of 2 is equal to 1/3. All right, let's do this last one. We have 7 to the y is equal to 300. Well, what's our base? Well, our base is 7. So we write log base 7 and then swap these. So 300 is equal to y. So this says that log base 7 of 300 is equal to y. Again, your bases stay the same and you swap those numbers. The next 4 examples ask us to go the other way. It says take the logs and write them as exponentials. Now remember, when you're doing this, identify your base, switch the x and y. So let's try the first one. Log base 9 of 3 is equal to 1/2. Well, which one is the base? The base is 9. Now I need to switch. 1/2 goes as the exponent, 3 goes on the other side. So I switch those x and y, if you will. So these things get switched out. So 9 to the 1/2 is equal to 3. What about the ln of e is equal to 1? Well, what's my base? Well, remember, ln, that's log base e. Correct? So your base here is e. So this is saying e, and then swap these numbers to the first is equal to e. Let's do example 7, which is similar. I have the log of 10. Well, again, I'm missing a base. If it says the word log and you're missing a base, that means log base 10. So the log base 10 of 10 is equal to 1. So what's your base? It's 10. And then you swap these two out. So 10 to the first power is equal to 10. Let's look at example 8, and then we're going to move on to graphing logarithmic functions. So example 8, log base 5 of 125 is equal to y. So what's your base? Your base is 5. So 5, and then swap these out. 5 to the y is equal to 125. So really important to remember that base is the same, and then you're swapping those x's and y's. The next video, we're going to deal with graphing logarithmic functions.